Okay, hello everyone. This is Ivan Francis Orozco, and for this batch, okay, but wait a minute. I have a little bit of announcement. So the National Olympiad on Informatics, the Philippine leg, is due on 3 days. Okay, more than 3 days. So in this recording, this video has been recorded in June 24. Hopefully, it will be up tomorrow. Okay, so actually, let's go back to their problem set in HackerRank. Okay, so in the previous video, the mock problem set has 6 problems. We solved 2 of them, sharing chocolates and the slippery slope. So in this video and the 4 succeeding videos, we will be solving all of them. Okay, so the guys at NOI were kind enough to release an editorial containing hints and solutions to the problem set. So the goal of this video is to do an actual implementation that would pass, okay, the or an actual solution that would pass their test data. So we would actually code, okay, for this type. So um, the next problem that we'll be solving, okay, is the third problem, alien defense. Okay, so essentially, in alien defense, we're just given a number n. Okay, first line is n, where n is between 1 to 1,000, and the next one are coordinates of a box. The next n lines are coordinates of a box. But actually, if you are going to be specific about it, the first 2 values are x and y coordinates of the box, and next 2 values is the width, so uh, x plus the width and the height, which corresponds to the y coordinate. So the goal, okay, of solving this problem is to have to display the first the intersection of the n rectangles and the union of the n rectangles. So let's start. So actually, for the first part, okay, let's do this by 2 parts. For the first part, we deal with the intersection of n rectangles. So we compare 2 rectangles at a time. Okay, an intersection of a rectangle and another rectangle is just a rectangle, provided that the intersection is not null. Okay, so if these are null, automatically the intersection of n rectangles is null. Okay, so I hope I would explain this well, since um, the the intended student the intended listeners are high school students, so hopefully this goes well. So let's have the following figure, example 2. So we have 2 rectangles here, and for this part, these are squares. Okay, so imagine, just take a look at the 4 vertical lines here: line 1, line 2, line 3, and line 4. Okay, so as you would notice, the smaller square, okay, let's call them squares since they are squares. Okay, this is a 3 by 3 square, and this is a 5 by 5 square. So the left square, okay, is has smaller x values, okay, than the larger square. Okay, so whenever we get the intersection, okay, of the two squares, we have this one, this bar, and then this bar, right? So the intersection, okay, the least of the values of x is, okay, the greater between the greater x value of this one and this one. So obviously this would be um, part of the intersection. Okay, so the left side would be the greatest value, and for the right side, okay, it is just reversed. The value of x would be the least values of the two. So this one is less than this one. Okay, so actually the lines that I'm talking about are r1 of x and r, oh, this is not r1, this is ri, sorry, ri of x and x sub 1 and ri of x sub 2. Okay, so ri of x sub 1 is the maximum value of r1 x1 and r2 x2, so the maximum of these. And then um, ri of x sub 2 is the minimum of r1 x2 and r2 x2. So this is the this would be part of the intersection. Okay, so and um, a given condition is that r1 x ri x1 is less than ri x2. Okay, so the values of this one should be less than this one. Otherwise the intersection would be 0. Okay, so let's do that. Actually, for the intersection and union, I found a cool piece of code in Topcoder. Okay. So actually, there is a similar problem, okay, called box union. This was used in the single round match or the competition SRM 237 of Topcoder, wherein you are given the coordinates of three rectangles, and essentially you are to find the intersection and union of them. So this problem is similar. So what's interesting in Topcoder is that for each competitor, eh, that actually the essence of Topcoder is similar to that of HackerRank. Programs are submitted through some of the interface. Okay, actually in Topcoder they have a facility wherein you would download the interface. Okay, so it is a desktop application, and then paste your code and essentially run it. So they have an archive, okay, of all of the competitors codes. Okay, so we have a player here called I'm Too Good, okay, a level 2 player. Okay, so uh for the top coder, players are categorized into how many levels? As far as I know, 5. Level 1 is the topmost players. These are players having fonts red. Level 2 is yellow. Level 3 is blue. Level 4 is green. And level 5 is gray. Okay, so anyway, what's important is that I'm Too Good has a good solution for getting the intersection of two rectangles, which is really similar to the one posted in the answer sheet. So we'll try to integrate that in our program. Okay, so for today we'll be okay, okay, calling our program prog03. Okay, and as always we have a class name solution. Okay, so actually what's good in HackerRank is that for Java You can have more than one class. Okay, but your entry point, your main method should be within solution. So following the code of I'm too good, he must be a good player since uh, in top coder there are two um, divisions, division 1 and division 2. Division 1 is like a higher league play, and division 2 is just like a the lower leagues. Okay, anyway, so we introduce four variables: min x, min y, max x, and max y. So next, we define a constructor for rectangle wherein we take in four values: x1, y1, and x2, y2. So min x, y, x. Okay. Next, we define an intersection of a rectangle, okay, wherein our output is another rectangle and our input is the second rectangle. Okay, so following this formula, okay, we return a new rectangle. Okay, so the first part we get the maximum values of x1. So we have that max of min x and then r of min x. Okay, so the one that has no class name is the first rectangle and r is the second rectangle. Okay, parameter 2 y. Okay, it's the same. It's the maximum of min y and r of min y. Okay, parameter 3. Okay, x2. It's the opposite. It's the mean, that mean of max x. Okay, actually the mnemonic is the max of the mean and the mean of the max. Okay, r of max x. Okay, and the fourth one is the mean of max y and r of max y. I hope I got it correctly. So min x, min x, min x, min x, min y, max x, max x, max y, max y. Okay. So next, so the values for this one is x and y's are from negative 10,000 up to, oh no, not 10,000. It's 1 million. So their area, okay, is of a long data type. So if we get an area of a rectangle, okay, if min x is greater than max x, then okay, no area, and then min y is greater than max y. Return 0 area. Return 0 as their area. So we return max x minus min x plus max y minus min y. Okay. Max x minus x and x, y and y. Okay. The problem in this part is that when I previously run, it displays an integer, so to be safe, let's typecast them as long. Okay. Because in Java, when something overflows, it doesn't throw an error, it's just wraps around, so I get weird values. So for the solution, we add a main method. Okay, so we have the obligatory scanner. Okay, for the next one, we have to get n as the input. Okay, and scanner. Okay, close it. Then, okay. Okay, so first we have for arrays. Okay, so we have uh, what do we call them? X, Y, W, H. Okay, this is not in. Okay. Whoa. New scan. Okay, so we have int x new int this is n. We define for arrays, so I guess it should be x, y, w, h. Okay, and then we get the four values for n values. Okay. Just want to call them x1, y1, x2, and y2. Okay. So x2 is just, since we're getting the width, okay, let's add the previous values, right? Okay, and scanner that goes. Okay, so next we define our rectangle to be x1 of 0, y1 of 0, x of 0, y of 0. Okay, so for int ctr1, ctr, so we get the second rectangle, right? And then we get the intersection of, so this is the first rectangle, so from the second rectangle up to the last rectangle, so A is equal to rectangle, that's intersection, right? Okay. Whoa. I'm sorry. So we have to introduce in, okay, object-oriented programming in Java. Okay, so we could further optimize this program by saying if a that inter that area right, is equal to 0, then you can break from it. So if the area is always 0, okay, no need to check them. Okay, so next we display the result. Here. Okay, then run the program. So first we check. Oh, this one. Okay, so first one is just trivial, okay, one by one rectangle, and then second one are two rectangles. Okay, so 0, 3, 3. Second one is 1, negative 1. Okay, 1, negative 1. So okay, the answer should be 6. Okay, so far so good. So this is the easy part for the um, for the for the intersection. So the harder part for me is the union of rectangles. So the NOI guys suggested that we suggested 4 algorithms. Okay, but if you don't want to go through these 4 algorithms, okay, someone in top coder solve it. Okay, actually in top coder the test cases are pretty much gentle. The number of triangles, the maximum number of triangles are just 3, but for our in our case the maximum number of rectangles is 1000. So if their test data is only up to 3 rectangles, you can do brute force by using set theory. Okay, but a top coder player by the name of, okay, let's just load his replay. Okay, let's just wait for a couple of minutes. Okay, so a top coder player, okay, as Neil, a yellow algorithm player, provides a generalized form of finding the union of rectangles. Okay, so essentially what Snail did is that, okay, actually a naive algorithm for this one is that we store a one by one box in a two-dimensional array. Okay, we draw the whole of the boxes and the whole figure in a two-dimensional array, and then store them and then count the ones that are shaded, so we get essentially the union. But our test data is what, 1 million by 1 million, so we have 1 billion of these boxes. So even in C it's really slow. So what Snail did is that he just took the important parts. Okay, so the sides and the intersections, actually the sides of the rectangle. So essentially he stored for the x coordinates the values 0, 1, 3, and 6. Okay, and for y he stored negative 1, 0, 3, and 5. Okay, so this is his algorithm. So what he used, okay, let's just rename the four arrays x1, y1, x2, y2 to LBRT. So we have L, R, left, right. What does B and T mean? L, R, B, T. So this is L, R. Okay. So L, R, B, T. So L, R, B, and T. Okay. So let's run it. So the answer is more or less it's still the same. Okay. Okay. So for snails, right? It's snail. Okay. For snails algorithm. So here goes. So he has two variables cx and then cy, and then he save all of the values of the sides in coord x. So here we have 2000 values. So since we have 1000 of rectangles, okay, 2000 should be sufficient. Okay, and then we initialize them. Array that fill coord sx. Essentially we'll be sorting them, so we'll assign a huge value. Okay, and then we'll be getting them from these arrays LRBT. So we have arrays. Oh, it's array, sorry, not array. Okay, so we have for int I is equal to 0 less than n plus I. Whoa. So import arrays from Java.util. Okay, so we have coords of cx is equal to li. Okay, and then increment it. Okay, so do the same for cx, cy, cx, and cy. L, brt. I like to double check there his convention, so it's lbrt. Okay, lbrt, lbrt, and this is lb. lbrt. Okay. Are the values still intact? Seems to be. Okay, so next we have coords x, y, x, y. Right, and then next we have to sort it. Okay, next. So what we have here is that, let's say we print it. We print the values. Okay, so for int I, let's see here, cdr is less than or less than length. If these are a lot of values, 2000 values. Let's print the significant ones. System points. Okay, so let's print our values. So we have here 3 and then 1. Oh, x1. Ah, okay. 0, 2, 0, 2, 1, and 1. Oh, it's 0. Okay. 2. Okay, so we have so essentially we store the coordinates. Okay, for the next part we have to the values here should be distinct because I could do this. So 0033 and then 0033. Okay, we have repeating values, so we have to retain only the distinct values. Okay, so what Snail did is that introduced another variable k. So 0 is less than 6 I k. So if kx is equal to 0, k equals k x minus 1, k for sx of kx is equal to 4. Okay, for sx of I. Okay, and then we increment that. Okay, next we have for int I is equal to kx, I is less than cx plus I for sx of I is equal to integer dot max value. Okay, that's for x. We have to do the same for y. Okay, ky is equal to 0 for x1, ky minus 1, y, ky is okay, right? Oh, almost forgot. Okay, so let's check. Okay, so if we run example 2, nothing significant happened, but if we do this 0033 and 00, let's say 44, okay, essentially the two zeros are doubled. So since this is a duplicate, what this code does is it removes them. Okay, so next we'll be declaring a two-dimensional array. Okay, so for snail, yeah, okay, for snail, this array is was. Okay, so we have a 2000 by 2000 array. Essentially, we have a two-dimensional array of 4 million elements. Okay, but it's enough to solve the problem. So int okay, okay, next one, we store the union. So we have a long value here. Okay, because the area could be what again? Uh, the area could be 1 trillion. That's right, and 1 million by 1 million. Okay, okay, 1 million by 1 million. Okay, so first we have an array for int k is equal to 0, k is less than n, so it's k. Okay, so int ls. Okay, first we determine the position array, the position in the two arrays, okay, of the numbers that we okay in, inputted. Okay, the two so we get the values lbrt in coord x and coord sy respectively. Okay, so we just so essentially ls, bs, rs, and ts, they are the positions of l, okay, brt in the array. Okay, so l brt l brt, okay, sx and sy. Okay, next we say that this is x1, right? It should be greater than it should be less than, okay, of r. Okay, l should be less than r, and b should be less than t. Okay, if one of them is greater than, okay, then the area is 0, so just continue. Okay, so next we just have two for loops, okay, from ls to a value of rs. Okay, so we're getting the coordinates of from ls to one index lower than rs. Same is true with BS and TS. Okay. What? Oh, okay. So we set the two-dimensional array. If this partition is filled with a rectangle, obviously it has a value of 1. And then we count the number of ones, and then we multiply them by their dimensions. So in this part, we fill the was two-dimensional array with ones, and then we essentially find their area. Okay, so I is equal to 0, I is less than kx. Okay, so kx is this value, right? The compressed one. Okay, the values with distinct numbers. Okay, and j is equal to 0, j is less than k1, plus 1, j. Okay, why is there minus 1? Because we're just getting the left side for x, and right side the bottom part for y. Okay, there's a plus 1 in the formula, don't worry. Okay, so if was of ij, okay, it's equal to 1, then we add the result, or s x of I plus 1 is scored as x I. Oh, okay, and then so this is the width times height, right? Hopefully it's correctly. Then essentially these are integers, so we have to typecast them for them to be long, so that okay. I'm sorry, it should be this one, right? And then we have yes. Okay, hopefully this works. It's a pretty much long algorithm, 150 lines. 2, 3, 1, 1, 5. Ooh, array out of bounds. 1, 3, 5. Okay, should be B. Okay, hope this works. 3, negative 1, 5. Okay, so it's 28. So let's just delete our print line, values for print line, and hopefully not delete the code. Okay, so okay. Okay, so we have run. Okay, then 2, 0, 3, 3, 1. Okay, we have 6 and 28. 2028. Okay, so let's we set this to Java. Okay, there is reflect and array. Whoa, why is there an R here? Okay, okay, so let's test it. Okay, both cases pass, submit code. Okay, test case number 8. Okay, so okay, all of the judges, 22 test cases, we passed them. So that's solution for alien defense. So it is solvable by the use of Java. Okay, so this is it for problem 3. See you on the other video. Thanks for watching.